Good morning, ladies and gentlemen. We're waiting for a few more people to join the webinar. We will start in exactly 5 minutes from now. We only have 5 delegates at the moment. Thanks. Good morning, ladies and gentlemen, and welcome to today's webinar. I'm Buhle Kakalashe, a Chief Engineer in the Pyrometallurgy Division at Mintech, and I'll be chairing this webinar. Thank you all for joining in this morning for yet another exciting SIMM webinar. Let me take this opportunity to introduce to you today's speaker, Mr. Riaan Bergh. He is passionate about performance testing of safety products. He has 18 years of experience in structural testing in the mining industry. Bergh developed and honed his skills in the early years of his career as the test engineer of an engineering consulting firm. Riaan joined the CSIR in 2010, heading up the mechanical and wire rope testing activities at the well-known Cottesloe Laboratories. As the manager of the CSIR mining cluster's mining testing and training impact area, he believes that product testing plays an important role in providing a safe working environment in South Africa's mines. Back to today's talk. It is an important one related to safety in mines and industry, and is entitled Test Protocols for Credible Performance Assessment of Safety Products. The webinar will illustrate through a number of case studies the importance of proper definition of service loads and selection of appropriate test protocols. A simple yet effective approach is proposed to arrive at a test protocol that will yield credible results. Finally, the cost and benefits of a sound test approach is weighed against the risk associated with unreliable test results. And for your information, ladies and gentlemen, the presentation will be circulated to the attendees, and please kindly ask your questions under the Q&A tab and not on the chat, as we could miss your questions. Over to you, Mr. Bergh, and looking forward to an engaging presentation from you.
Good morning, everyone, and thank you, Butle, for the introduction. I would like to start by just putting the presentation up. I trust that everyone will be able to see it. And then I would like to say thank you to the South African Institute of Mining and Metallurgy for giving me this opportunity to share a few thoughts on the topic of test protocols for credible performance assessment of safety products today. So it is my pleasure to be presenting today, and let me just give you an overview of the topic that we will cover. So first of all, I would just like to say a few words about the need for testing, and then lead in with standard test methods and a short discussion about that. I think a presentation about testing of safety related products would be incomplete without a mention of test accreditation. And then I'll speak somewhat on test protocols, agreed test protocols, the topic of recreating service loads and what pitfalls to avoid, sharing something from our experience in testing, and then to wrap it up. So why do we test? I think the world today has become so digital and digitally enabled that in the engineering field, when we think about assessing a design or a product, the first thing that may come to mind would be to do a very well-developed computer simulation, putting all the boundary conditions in and seeing a beautiful, often colorful graphic test results showing high stress areas or predicting the areas where failure will occur first. And surely simulation has tremendous value, and one should make use of that, especially in the development phase. However, the point that I want to make here is that despite the big value that simulation has, there are certain advantages from physical testing that one must always keep in mind. Now, the diagram on the right, I'm sure everyone is familiar with. One can have a beautiful model of the scenario, but if the input data into that perfect model is not good, your results will not be reliable. And similarly, you can have perfect data of the, let's call it the boundary conditions, the load conditions, the constraint of the item, but if the model is lacking, you also don't get results that you can rely on. So a key advantage of doing an actual physical test is that you sample from the actual product, and then if there are real world imperfections in the product, those are included in your test result. Another advantage of doing an actual test is once you have created a beautiful model of the scenario, doing a test with valid boundary conditions in the test setup gives you an opportunity to validate your simulation. You can then go ahead and do a number of variations of the product or variation of certain boundary conditions having validated the simulation, and you can have greater reliance on the results that you get from the simulation. A few more reasons why testing is useful. The first is to confirm material properties. Now, in many cases, your product may come with a material data sheet, but I would like to describe an experience that we had early on in my career at the CSIR, where a combination of unidentified or unanticipated failure mode and eventually what turned out to be material properties that were not as required resulted in quite a bit of work, extra work over a weekend and a missed Springbok rugby match. So just by way of quick background, the photographs you see in the bottom there is a sample of a large size triplex drive chain. To give you an idea, the width of the chain, as you see it in the picture there, is just over 0.5 meter. And the customer required a proof load test to confirm the integrity of the chain, but he also needed to confirm that the ultimate strength was above a certain minimum threshold. So we designed the test fixtures that you see in the photograph, and the test fixtures design took into account the different failure modes that we were taught in university undergrad. And we realized pretty soon that the material had to be of quite a high tensile grade, because the chain elements are also of a similar high tensile grade. So within the size limitation of how you can attach to the chain, it predicted or prescribed that the material had to be of, if I recall, about an 800 megapascal yield strength, which the manufacturer of the test fixtures indicated that would be no problem. And lo and behold, when we had everything set up and we did the ultimate strength test, as you can see in the photograph there in the bottom middle, it wasn't the chain that failed, but the test fixture. So plans had to be made and extra work done. Not a pleasant experience. And what we learned from this was the bursting open or the fracture of the clevis tongs at the end in front of the pin was a failure mode that wasn't anticipated. And had we been doing tests on items of this nature and having seen destructive tests where a similar clevis type was tested to destruction, we would have anticipated that failure mode as well. And secondly, if we had insisted on a materials test certificate of the material that the test fixture was made of, we would have known ahead of time that this fixture was not at the required tensile grade. Unfortunately, we found that out after the fact in doing a bit of cause analysis, but it all could have been prevented had we insisted on a material test certificate for this material post heat treatment. So a few more reasons here. The last two that I would like to share with you, why testing can be of great value. The first one would be evaluating the item evaluating the item as it is in service. The picture of the steel wire rope there, the corroded steel wire rope, is of relevance here. And this relates to an experience or an example that we have from the wire rope test laboratory, where we test routinely steel wire ropes from mine winder installations, but also from time to time from other applications And the particular one that I have in mind was from an ocean-going vessel, the winch installation on the ship, which the company sent us a sample of. And on the outside, the rope looked more or less like the one in the picture. It's not the same one, but it had about this appearance of corrosion. And one would not have been able to say on appearance of the item what its strength would be. You might think that it's maybe a little bit degraded because of the loss of material on the exterior. But when we tested the rope to destruction, we found that it had only about 38% of its rated strength remaining. And the condition on the interior of the rope was actually quite more severe. There were many of the wires were corroded down to needle points, and on the inside of the rope, when we took it apart to inspect it after the test, we found that there was handfuls of corrosion material, rust essentially, that made up the inside of the rope, and not much good steel. And you can imagine that if one hadn't done that test, it could have led to a catastrophic incident if the rope had been put to anything close to its actual intended service strength, maximum service strength. And the last point in this example, or reason why we benefit from doing actual tests, is risk management. Despite the best design calculations and material tests, errors can still creep in the manufacturing process. And once you have a complete product, if you then put it through an ultimate strength test or a proof load test, it gives you objective evidence that the product can at least perform up to the minimum required performance criteria. So this is something that we do for each and every mine winder rope that is installed on licensed winders in South Africa. And the large diameter rope that you see in the bottom left picture is not for a mine winder application, but that was actually a rope made for a heavy lifting application. It was probably going to do only one lift. And it was of utmost importance that everyone had confidence and knew with certainty that it would handle the load that it was going to lift. As part of a multi-point lift arrangement, a single failure would have been catastrophic and completely unacceptable. A few comments about standard test methods. So what is a standard test method? It's when a document provides detailed directions of how to do the test and how to produce the test result. A standard test method provides a basis for laboratory accreditation programs, and it also allows inter-laboratory comparison of test results. The institutions that you can see the logos of at the bottom are examples of institutions that publish standard test methods. And if we, one of the benefits that we derive from following a standard test method or applying a standard test method is that we don't come up with a test method just based on our own experience and our own wisdom. But we have the opportunity to draw on the expertise and the competence of national and international experts in the field. So we can stand on the shoulders of giants, as they say. But standard test methods are not always available, and we'll get back to that in a few minutes. So not the most interesting slide to show you, but as I said, one needs to at least touch on test accreditation. This can be a webinar in itself to get a better understanding of the accreditation of test methods. But let me just touch on a few main points. So first of all, as one might know, in South Africa, the institution for accreditation of test methods and also a number of other conformity assessment functions is SANAS, the South African National Accreditation System. And so when we speak about accreditation, it's often called SANAS accreditation, so we know why. It's important to note that in the case of testing laboratories, it is not the laboratory that is accredited. In other words, if you receive a certificate that has the accreditation, the SANAS accreditation mark on it, it does not imply that the laboratory that performed the test is also accredited for all the other tests that they carry out. Accreditation is awarded by SANAS for the specific methods for which the laboratory applies and for which they demonstrate competence. However, and this is why I've unpacked just briefly in a few main points the requirements for accreditation in the bottom half of the slide. The however part is that if a laboratory has accreditation for a number of methods, it also tells us something about the quality management and the systems and the processes and the environment and the competencies in that laboratory in general. Why do I say that? If we just take a look at the main parts, the main areas that a laboratory needs to have covered in order to achieve accreditation for a method, it covers general conditions, including impartiality and confidentiality. It means those things are documented and enforced in the laboratory's operations. The structural aspects, for example, the organizational structure is presented to SANAS and it gets confirmed that there are no conflicts of interest. The resources are covered, that includes personnel, the facilities, the equipment, the traceability of measuring equipment, the national standards. The processes are covered, that includes contract review, the selection of a method and how the method is verified, how the sampling is done, record keeping, understanding uncertainty of measurement and how that is incorporated in the reporting of results. And then also the management system in general. That includes how the management system needs to be documented, how records are controlled, how risks and opportunities are identified and reacted to, how the laboratory does corrective actions and the need and the execution of management reviews and internal audits. So you can see that a laboratory has to cover quite a wide range of things, comprehensive range of things, to have one method accredited. And once they have that in place, it would be easy for other methods that are even not accredited to also benefit from I would say a sound management approach and good laboratory practice, as one would have to have even to have accreditation for one or a selected number of methods. So that is maybe perhaps a case to opt rather for laboratories that do have accreditation for some methods, even if they do not have accreditation for the particular method that one uses. But the learning that we can share in this regard is if the method is not accredited, then the onus is on the customer to satisfy themselves that the laboratory is also competent in the method that they require, that the customer requires. Sometimes an accredited laboratory is not available for the particular test that is required. Then one can go ahead and do that, but it is incumbent on the customer, on the end user of the test, to confirm that the laboratory is competent. And that might mean simply going to the laboratory, paying them a visit and telling them, how will you do the test? Asking them, show me what the test setup is going to look like, what equipment is going to be used. Is this load cell calibrated? Can you produce a copy of the calibration certificate? Is it traceable to an international standard? Do you know what the uncertainty of the measurement is and how will that be used in interpreting whether my product meets the performance criteria or not. These are all relevant questions that the customer is quite entitled to ask of the laboratory, especially in the case where the method is not accredited. So a few thoughts about agreed test protocols. So agreed test protocols is what comes into play in the absence of a standard test method. So when a standard test method is not available between the customer and the laboratory, there needs to be agreement on the objective of the test. And it may seem like a trivial point, but in the absence of a good understanding on both sides of the objective of the test, it can easily happen that a test is done that does not meet the objective, that misses the mark. An important thing to also understand is what is the requirement or requirements of the end user. And maybe a comment about this in the particular case of the mining industry. In many of the tests that are submitted to the CSIR test laboratories, the customer that brings the test to the CSIR is the manufacturer of the product who wishes to sell it to mining companies. The end user is going to be the mine. And in a case like that, it is also important for the test laboratory to understand both the requirement of the manufacturer of the product and of the mine, or for, at least for both of these, to be taken into consideration when deciding on the test protocol. The next point of importance is replicating service load conditions. And by that, I mean, as far as is practically possible, one needs to aim to get a close approximation of the boundary conditions, how the item is constrained when it is in use, and how it is loaded, what the load looks like, the magnitude of the load, how the load is applied, in other words, the load path through the component to put the correct parts of a component under stress. A few comments about recreating service loads. So a good starting point is to have a sound understanding of the actual service load conditions. And then in discussion between the laboratory and the customer to select an appropriate test protocol. That includes how the item will be constrained in the test machine, how the load will be applied, perhaps including how many samples will be tested, if not only one, and also what will the performance criteria or the acceptance criteria be. It's not always possible to test exactly, to replicate exactly the actual load condition, but it is important to discuss and agree on valid approximations where approximations need to be made. I'm reminded of the expression that in engineering, and this is from my undergrad days, in engineering, an engineer will approximate a horse as a sphere just to make the math easier. Now that is perhaps an extreme example, but approximations are often necessary, but they need to be valid and they need to be understood and agreed. And then consistent, competent test execution. And this goes back to my earlier comments regarding accredited laboratories and the importance of the customer confirming for themselves the competence of the test laboratory. It can also be based on recommendation or confirmation of others, but the best is always to get confirmation for oneself. So in relation to recreating service loads, I'd like to share a little bit of a background or a case study, if you like, about two categories of product where traditionally test methods did not recreate the boundary conditions and the actual load application very well. And through the work of a number of people in the industry and working together with the CSIR, an improved test method was arrived at. And this was also featured in an article that featured in the Journal of the South African Institute of Mining and Metallurgy a number of years back. So I'm not going to go into too much of the detail of it. The journal article is there for everyone to read as well. But it relates to the specific example to tendon straps, which I'll show in the next slide. But we've also found it applicable to welded mesh, as you can see in the photographs in this slide. So the photo bottom right shows a typical test fixture setup for a welded mesh test that does not approximate the boundary conditions very well. And similarly, on the next slide, one can see on the right-hand side, these tendon straps are fixed into the test machine jaws at each end with a clamp mechanism that ensures that the tensile force is more or less evenly distributed across all 5 of the rods of the strap. Whereas if one considers how a tendon strap is installed in the mine, the photograph on the right-hand side will show that a typical installation with anchors and some form of a sturdy washer, in this case square, sometimes they are round, and typically they grip only on 2 or maybe 3 of the longitudinal elements of the tendon strap, and often the spacing or the placement of the strap relative to the anchors is such that the eccentricity causes only 1 or 2 of the longitudinal elements to carry load. If a block was to load the tendon strap somewhere around the middle. So the same is true for the mesh in this example. This is not the way that a mesh is installed in the mine. It's typically constrained at 4 corners only. And so a different type of test configuration was designed and is now implemented regularly, where the constraint is closely resembling the actual application in the mine, and the load application is not a pure tensile test, but as you can see in the photograph in this slide on the left-hand side, the load application is by means of a vertical component or element that is loading the mesh or the tendon strap in another setup perpendicular to the plane of the mesh or the tendon strap. That gives a better approximation of the load application of a block of material loading either from falling from the hanging wall or dislodging from the sidewall. And then a few more pitfalls to take note of and to avoid. The one that I represent in the photograph here is one of inappropriate acceptance criteria. The example here was of an industrial shelving product, and when the product was specified, it showed a certain load capacity per shelf, but the fine print or the detail, as they say, is that the load capacity was specified as a uniformly distributed load. And when the product was put to use, there were instances of damage to the product, to the shelving system, and that resulted from the actual loading in the warehouse not being a uniformly distributed load, but in many cases a more localized or concentrated load, as one is replicating in this photograph with load mass blocks positioned in very specific areas of the shelf and piled on top of each other. So we went through a whole series of tests with this product, where we first established it can, in fact, carry the distributed load. So the product specification was in order, but the acceptance criteria for the particular application was not accurate for the user case. And that just showed us that when one buys a product, when one starts into the procurement process, it is important to keep the actual use case in mind and to specify that in enough detail so that the product supplier can indicate whether it can meet the particular performance or acceptance criteria that would satisfy the need. And then lastly, two more pitfalls to avoid would be one of an unrepresentative sample. And here I'm reminded of the case of a steel wire rope that failed in service, and a sample of the rope was sent to the laboratory to do a destructive tensile test to confirm the tensile load that would cause the rope to fail. And it was difficult to understand why the failure occurred, because the tensile strength of the rope sample that was sent to the lab was still well above the applied load on the day of the failure. But after some investigation, we requested an additional sample to be sent that was taken closer to the point of failure. And it turned out that in this case, the rope had substantial localized deterioration, and the breaking strength of the rope in the area of failure was not even half of what the rope strength should be. And so that underscored for us the importance that if you need a sample to tell you something about the performance of the rest of the product, it is imperative that you select the sample in the right way, and that you confirm that it is of a similar quality or a similar condition as the larger lot that you want to evaluate. And then lastly, inconsistent test protocol. And this is something that also connects back to the comments about standardized test methods. In the case where a standardized test method does not exist, and where testing is repeated from time to time, it is very important that the test protocol should be documented, and documented in enough detail to allow either the same laboratory or a different test laboratory to be able to replicate that test, because it's only when you have consistent test protocol that you will be able to compare test results of the same product over time, or to compare perhaps competing products or dissimilar products from different suppliers against the same criteria to inform for example, a purchasing selection decision. So just to conclude, simulation definitely has its place, but as we've seen in this presentation, so does testing. Once the decision to test has been made, it is important to select a competent test laboratory. Where possible, opt for a standard test method. But when not, important to discuss and agree on the test protocol to ensure that it satisfies the need. It is important to understand the purpose of the test and aim to recreate or approximate as close as practicable the real load conditions, and one could also add the actual boundary conditions. And then between the laboratory and the end user or the customer, as it may be, agree on appropriate acceptance criteria or performance requirements to avoid the situation where the laboratory reports on the product and it may be seen to be not meeting the criteria, whereas in actual fact it could be good enough, but the criteria was perhaps not properly defined. thank you, and I hope you have found this informative, and I would be happy to take questions.
Thank you very much, Riaan, for that highly educational presentation. So, ladies and gentlemen, please feel free to ask your questions under the Q&A tab. At this moment, at this point, there's no question as yet.
I'm happy to stay on for a minute or two in case someone does have a question.
Okay, I do have a question then in the meantime. Testing according to local or international standards test methods are always preferred. So local and international standard methods, when available, are they comparable, or the criteria for those?
Yeah, that is often the case. We find that our South African national standards often make use of the process of adopting international standards, or I think adopting is the correct word. So one example is the ISO 17025 standard for the competence of testing and calibration laboratories. That standard you can also buy as a South African national standard, and the content is pretty much verbatim the same. So it is a standard that was adopted as a local standard without changes. And it may also be that international standards are used as the basis to adopt and perhaps to some degree adapt for local use, for the local environment. But in many cases, one finds that your national and your international standards are equivalent. You can also find that international standards may among themselves have large degree of equivalence. But the important part is to really closely read the scope of application that's normally in the front of the standard, to confirm whether what is contained in the standard is applicable to the particular user case or the particular product category that one is interested in testing.
Okay, thanks, Riaan. So a follow-up question. I noticed that the SABS is on your list of clients where they have their wire rope samples tested. So does that mean that you collaborate with the CSIR? Yeah, sorry, with the SABS.
Yeah, perhaps one must be careful with putting the logos of other entities on the slideshow. The SABS logo I included there as an example of institutions that publish standard test methods. But to answer your question, we do work together with the SABS. Some of our engineers serve, and myself as well, serve on the technical committees of the SABS together with other people from industry often. And these technical committees are responsible together with representatives from the SABS to work on the development and the revision of standards from time to time. So that is one way that we do work with the SABS. And there are other examples as well. One might mention the approval testing of the self-contained self-rescuers, or rescue packs as they are also known, where the full series of tests prescribed in the national standard for that product category is handled by the SABS and the CSIR collectively, together with the involvement of mines rescue services. So those items, those products go through an extremely rigorous test protocol, and some of those are handled by the SABS and some of them are handled by our self-contained self-rescue laboratory. So that's another example.
Okay, thanks, Riaan. It looks like our audience or the delegates are quite shy. There are no questions at this point as well. So again, I will ask one more question, and then we see if we get more questions from from the delegates. So you did mention that all mine wire ropes for licensed mines in South Africa are tested. So is there a way of getting around for customers? Because you mentioned for licensed mines. I mean, I'm asking this question given the safety risks of not testing or of unreliable test results.
Yeah. So let me just see if I understand your question. Are you asking if other ropes also get tested, those that are not from licensed winders?
Yes, correct.
Yes. We certainly test quite a large number of ropes that are used in other applications, not on licensed winders, for example, on scraper winches. However, licensed winders, the rope testing is mandatory. It's a requirement of the regulation, and so it has to be done every 6 months. In the case of other wire rope applications, it is the prerogative of the mine official responsible for that particular installation to decide whether they want to submit samples for testing to confirm the integrity of the wire rope and how often they do that. Of course, the mine official responsible for that installation remains legally liable for the safety of the installation and the safety of the people working with it. So we would advocate for regular testing, but one realizes that there is a cost implication, and if one considers the life of the rope and other methods of assessing the condition of the rope, for example, visual inspections, it is often preferred to discard a rope on visual inspection on its external appearance. But our recommendation would certainly be to have the rope tested at regular intervals, or a sample of the rope tested at regular intervals, to assist with the assessment of its condition and to determine whether it's still fit for purpose.
Thanks, Riaan. That's quite encouraging. So is this in line with the best international practice?
I believe international best practice is for in all types of rope applications, except for overhead cranes and lift ropes. It's interesting, but in those two applications, we rarely find submission of samples for testing. When we test a sample from an overhead crane or a mobile crane, it is usually as part of a failure investigation, and there was normally an incident of some kind, and the rope is submitted for testing to confirm its actual strength. I think in the case of overhead cranes and mobile cranes, a lot of the risk is well covered through regular inspection by a competent authority, a lifting machineries inspector, or LMI. In the case of lifts, in other words, similar to winders, but only the type that you get in buildings, it's a whole different application where you don't have one rope carrying all the load as in a mine winder. You often have 6 or 8 ropes carrying the load, and each of those are strong enough to carry the full load. So it's a built-in factor of safety, if you like. And those are also subject to inspection, but I'm not so familiar with the inspection interval of those. But certainly in the case of winder ropes and ropes for general use in mining applications, also above ground, it is common practice internationally for ropes to be tested from time to time. Although I'm not familiar with legislation in other countries, I believe it is also legislated in Canada, but I'm not familiar with the detail.
Okay, many thanks for that comprehensive answer, Riaan. So I don't see any further questions under the Q&A tab. So on behalf of the attendees And also on behalf of the SAIM, I would like to thank you for sharing your insights and for the highly educational presentation. And also thanks a million times to the delegates for joining us for this webinar. So if you would like to say a few last words, Riaan, the stage is yours.
Thank you, Butle. From my side, once again, thank you for the opportunity to share a few points on this topic today. And thank you to the attendees for your time and your interest.
Okay, thanks a lot. And that's cheers.
Thank you. Goodbye.
Okay, so thanks everyone. That concludes the webinar today. So join us again in the next week or two for the next webinar. Cheers, everyone.